can go.
Hi and good morning, and welcome to this Flexim webinar in association with Health Estate Journal, the monthly magazine of the Institute of Healthcare Engineering and Estate Management, or IHEM for short. In the webinar, Andy Hammond, Managing Director at Flexim Instruments UK Limited, and Lars Vogel, Head of Market Management, Pharma, Food and Buildings at Flexim GmbH, who is Flexim's expert on energy efficiency applications, will be discussing non-invasive metering solutions for medical gases, liquids and gas utility real-time monitoring, as well as energy metering for HVAC, boilers, CHPs, heat exchangers and steam metering, and how easily such metering solutions can be installed without impacting on estate operations. Areas they will cover include O2 and medical gas monitoring, based on best practice experience with over 200 hospitals in the UK and Ireland, water safety monitoring, how to confirm minimum water flow velocities and temperatures for Legionella prevention, carbon net zero, reliable and flexible energy flow monitoring and balancing with the one for all technology, ultrasonic clamp-on, including steam. If you have any questions as the presentation progresses, please use the sidebar on your screen to put them. At the end of the presentation, Andy and Lars will do their best to answer as many questions as time allows. Andy, over to you to begin the presentation.
Many thanks, Jonathan, and thank you to everyone who's attending this morning. Hope that you find it useful and informative, and as Jonathan says, we'll answer as many of your questions as possible. So we wanted to start by discussing, I beg your pardon, sorry. Discussing our experience and background working with hospitals with regard to oxygen and medical gas monitoring. We've done an extensive amount of work in this area in the past 18 to 20 months. We'll then go into water safety monitoring, and then I'll pass to Lars, who will go into detail on how we can contribute to your carbon net zero goals. First of all, just for those of you who may not have heard of Flexim, it's a company that's been in business since 1990, so we're actually in our 31st year. We would have celebrated our 30th anniversary last year if it hadn't been for lockdown. But we're a company of about 450 colleagues worldwide, approximately 76 million euros in 2019. More than 70,000 flow meters used around the world. So for some of you, perhaps one of the bigger companies you may not have heard of before. For those of you who are UK based, you may not know, but every time you fly on an Airbus, the world's Airbus fleet is maintained using our flow meters for leak detection in the hydraulics in the wings and tail fins. And every one of the UK's nuclear facilities has to use emphasis substantiated instrumentation for safety critical duties. And we are the only ultrasonic clamp-on flow meter certified emphasis for use on duties such as safety critical cooling water around the nuclear reactors. So we are a high integrity meter, high accuracy, a meter that can be trusted and relied upon. Let's look at those oxygen applications. So basically, most hospitals will have a VIE, a vacuum insulated evaporator, usually one or two tanks. So you have your liquid oxygen stack tanks, a vaporizer coil or two that will turn that liquid oxygen into vapor. And then basically we're supplying to the hospital at approximately 4 bar. Obviously there's a control panel to look after all of that. Now, in days gone by, if we talk pre-COVID, systems are designed and they are rated to cope with expected demand. And we can see here that a typical demand for oxygen basic ventilators might be 40 litres per minute. Now, with COVID-19, obviously things got a little bit out of hand. The number of patients was rapidly ramping up. And you can see that if we have a single VIE cylinder, then at 1500 litres per minute, with 40 litres per minute, you're looking at a maximum of 37 patients. if we have two vacuum insulated evaporators, 6,000 litre per minute system, you could probably achieve 150 patients. But you can clearly see here that in a pandemic that we've never seen the like of before, that hospitals were suddenly beginning to become increasingly worried that their systems were struggling to cope with the demand that was rapidly ramping up. Now, when the system is under full demand, that rapid exchange of liquid to gaseous phase oxygen causes a rapid freezing of the evaporator coils. Now, that equally leads to inefficiency. So those coils have to be doused with hot water or with steam to keep them operating efficiently. And in all respects, this is limiting the capacity of oxygen you can deliver effectively to your critical patients. So the conventional vacuum insulated evaporator systems were designed with pre-COVID levels of demand, and all you needed was a system that would trigger a replenishment. And that system basically would give information on a hourly max, but usually once a day basis to say how many days of supply is available still at typical demand. Do I need to order a tanker to come and replenish my tanks? And frankly, that just wasn't sufficient granularity with the massive increase in demand that we saw through the COVID pandemic. So what's the solution? Well, the solution we were glad to propose is a clamp-on oxygen system. And this clamp-on system, basically you have two transducers. It's using a well-established physical technique called transit time. You might also have heard of it called time of flight. And basically we exchange ultrasound between the two transducers. One set of ultrasound is firing with the flow and gets sped up by the flow. And then the ultrasound sent against the flow gets slowed down, very much like rowing along upstream or rowing downstream. If you're with the current, you get sped up; against the current, you get slowed down. And the time difference is directly proportional to the flow rate. So that's the very simple method of operation. And basically, we found that we could install it on the VIE compound to give hospitals information on their main oxygen consumption. And for those hospitals that were larger, we can actually give them a great deal more granularity. We can install oxygen meters for each and every ward or theatre that may require that important information to administer their oxygen effectively and make sure no patients were left without that supply. Now, obviously, we have outputs from the meters. That's anything from a simple 4 to 20 milliamp to various buses. I think probably the most common we've done in hospitals has been BACnet, but there has been Modbus. And then that data can then be delivered to an oxygen monitoring and alarm system. In some cases, that's part of the building management system of the hospital. In other cases, it's a standalone oxygen monitoring system. So far, we've supported, and we've been very proud to do this, to help in this situation, more than 200 hospitals across the UK and Ireland. There are some quotes here from a number of hospitals. If you take the one at the top here from Martin Owen Martin at Leicester University Hospitals, he's the guy who first kicked this off with us. This is going back to March 2020, when the pandemic was first in its infancy, and Leicester saw this problem of limited oxygen supply. And so he pioneered the installation. It worked very effectively, and then we went on to supply all these other estates. There's one there from Lincoln. In fact, JWF is our partner in Scotland, and again, a nice reference there from Royal Alexandra Hospital in Paisley. So the bare minimum is 1 meter on your VIE, as you see on the left-hand side in the compound, but equally, for extra granularity, we can do individual ward demand. The O2 monitoring, it's giving you real-time oxygen demand. There's none of this hourly reporting or even daily reporting for tank replenishment. It's giving instantaneous live peak and average flows. That's obviously enhancing the local operational command within the actual hospital. and proactive prescription of oxygen within the known limits of the system. Very often these systems have enough capacity, it's just that the way that they were configured, there are bottlenecks in the system. And again, by having the metering, you can find the bottlenecks and you can more effectively distribute the oxygen. The installation is done without any outages, so there is never any supply interruption to the hospital patients. And of course, because it's not breaking into the line, there's no microorganism paths. We're not introducing any areas where bugs can collect. The output, FlexSim's responsibility ends with our output, which might be 4 to 20 milliamp, might be BACnet, might be Modbus, into a BMS or an oxygen system. And then there are many other companies who produce dashboards. Top left is our sales partner in Scotland, JWF, and the dashboard they've effectively delivered to NHS Scotland. But there are other companies like Dema, Inmetrics, all doing great displays. That led us on to other applications, and one of the key critical issues with any buildings, whether it's hospitals, whether it's universities, whether it's libraries, etc., is if you've got an air conditioning system, if you've got any or any water system, if you've got any standing water supports Legionella growth. And obviously, I'm sure every facilities manager knows that this is a key and critical point of control. So you've got to keep your hot water above 60 degrees C and distribute it at more than 50. Cold water should be stored and distributed at lower than 20 degrees C. You need to regularly cycle and flush the water so that there's no standing water. And those water tanks, basically a contractor will design and build a hospital, but you might not necessarily size the tanks to ensure that you're constantly getting that rotation of water. And ideally, you're really looking for less than 12-hour residence time. So we are quite often approached by hospitals and universities to look at, is their water tank sized appropriately to ensure that there is no residence time greater than 12 hours where the water can sit there and Legionella can fester. So Vale of Leven is an example where we've gone in, our colleagues, JWF, our sales partner in Scotland, have gone in with portable meters and have done flow surveys for more than a week, generated the data, and actually proven the size of tanks that are required. And I believe that resulted in a change of water tanks to ensure that that 12-hour residence time was achieved. Now, as well as portable meters, we can do fixed meters. And those fixed meters can have permanent PT100s installed. They can be giving you simultaneous information on temperature as well as flow, or indeed energy. We're going to come on to energy with Ulf. With Lars, my apologies. We have a low cost F501 meter, which will give just flow for residence time, but with 721 will actually generate temperature as well and give you temperature information. So again, with temperature information, you could ensure that there is no biological growth of bugs and such like. So that's the water safety monitoring. And at that point, I'm going to pass over to my expert colleague, Lars, and he's going to talk further to you about energy metering. Lars, over to you.
Many thanks, Andy, and a warm welcome from my side here from Germany. Nice to have you all here. So just to be sure, I now shared my screen. Is it visible? Should be. Annie, can you confirm?
Yes.
It is? I'll just move on. So we should see now the carbon net zero slide. Do we?
Yes, you're visible.
Sure. Pardon?
It's visible.
Okay,
yeah,
great. Thank you. Okay, perfect. Okay, so yeah, as Andy already mentioned, his story about the great oxygen projects we did with the UK and Ireland hospitals. Now we wanted to take the next step and also make awareness of the other solutions we provide for building industries, for hospitals. And I think there's a very known topic here, the carbon net zero, which the NHS speak out. So to really reduce the carbon footprint to a point where you can say we are net zero, that we are not producing more any more carbon or CO2, for example, to pollute the environment. So the scopes and targets, I think, pretty well known that you have this smaller scope of NHS carbon footprint reduced by 80% between 2028 and 2032, and with the goal of net zero in 2040, or the NHS carbon footprint plus. So a bigger scope, including more topics to reduce, with a goal 80% reduction 2036 to 39 and net zero 2045. So as you can see, I picked up here a picture which has been publicized by the NHS in their delivering a net zero National Health Service publication, showing the shares of where carbon footprint does come from, or where it is located. And you see, if you go to the smaller scope, which is highlighted in green here, that you have in this section 10% building energy. So this means in this smaller scope, the building energy that you use for heating, for cooling, and so on, including steam, for example, makes up 10% of your carbon footprint. So it is, of course, quite obvious to start there first. By reducing those 10%, you will have the biggest effect on reducing your carbon footprint. So basically, what is the idea in reducing, well, how to get there? Of course, it is much about having efficient machineries, running your boiler at efficient levels, not wasting energy in a matter of not to waste energy. So basically, what you need to know to get there is that you need to identify your energy savings potentials, and that is being done by knowing your internal energy flow. So to be aware of how much energy do I use, for example, to produce heat, to produce cold in my building areas, and where does it go? So where do I consume it? So by knowing those energy flows, I can easily identify excessive or unbalanced energy consumption areas, so that I have highlighted the areas where I can go first, where I have the biggest saving potential, so that I can have some kind of list. I see my top priorities and know where to start first and what will be most effective. So yeah, this then would be the areas where I can start with optimization, so that I can think about, okay, how can I reduce my amount of heating, perhaps by a better control of my heating system, or by probably reducing the hours of heating time without having without affecting patient comfort and so on. And the point here is, if I want to do all of this, and if I want to know my energy flows, I need to know about it. I need to measure it. So you cannot manage those energies if you do not measure it. So measuring would be the first step in this process of getting to the complete picture of your internal energy flows. So as Andy already explained, we have this one measuring principle, and this is very important for you because we only have this one measuring principle for all of these applications. So transit time measuring principle is something that is valid for liquid, for gases, and for steam, including energy measurements. So this means we have kind of an one-for-all solution for energy flows. And I'm going to show you some products here. So we already learned about the gas flow measurement for oxygen or for nitrogen, for example, but we have different configurations. For example, the Fluxys F721TE. TE stands for thermal energy, which is a fully integrated flow and energy meter. So you have an internal energy calculation. You can plug in to temperature probes, PT100 or PT1000. You even can plug in external 4 to 20 milliamp signals, and then let the meter calculate your energy flows, even up to a 2-channel meter, so that you can handle 2 different measuring spots with 1 meter. Of course, we already learned about the G721CA. So the CA stands for compressed air, but this is also usable or feasible for medical gases and compressed air, including of course, medical air, and also much more sophisticated solutions like metering gaseous ammonia, for example, in a refrigeration system. So if you have, for example, an ammonia compressor, which you can use for creating deep temperatures for a refrigeration process, we also have solutions to get you the information about your compressor output in your cooling system. Then we go further to the G722ST, which is our dedicated mass flow meter for saturated steam. So again, same measuring principle, same non-invasive principle, measuring steam from the outside, but we'll get to this topic later on and discuss this a bit more in detail. And very importantly, all of this with, again, same measuring principle is available as a portable meter. So you can see it in the picture here, the bottom right hand, this carrying case. This is battery powered handheld portable meter that you can use for all of these applications, so that you have really a multi-tool in your hand that you can carry around your estates and check your energy flows, to check your oxygen flows, to check your steam flows, everything integrated in this one meter. You would just need the right transducer for different applications, but basically you have a very powerful multi-tool which you can use to determine energy flows in areas where you do not want to install a fixed installed meter, where it probably is not necessary, where it's good to have to check it once a year or once every half a year. So to give you some images here, how it looks like in the field. On the left-hand side, this is a chiller application. This is actually from a hospital in Australia, where we have our 5 series meter installed to monitor flow, cold water flow from the chillers. As you can see, the transducer themselves, they sit in a stainless steel mounting rail, which is quite slim, so easy to insulate, so you do not have any energy loss by the installation itself. Again, this one for all solution where you do not need to worry about which kind of meter do I now need for this special application. It is really everything can be done with this non-invasive clamp-on meter, and it's very easy to design or to lay out for you, because the main thing you need to consider is pipe diameter and the proper transducer. So if you have an inquiry for a flow measurement, you can ask Flexim, which I have a need of a thermal energy measurement on the DIN 150 millimeter pipe. So this is the according transducer you need, and that's it. You do not need to worry about flow ranges or any other things. It's quite easy to lay out and to install, of course. So I said this will apply to heating systems, chillers, refrigeration, warm water, cold water, and of course steam for heating, cleaning, autoclave, and so on. So point here is, again, if you want to go this road of net zero, you need to understand what is happening in your system, and if you don't measure it, you cannot you cannot manage it. And so this is where we come in and provide the proper solution, because one other thing that is the big advantage of those non-invasive meters is you install it anytime and without any outages. So you do not disturb your operations at the hospital. Nobody will even notice that you have installed energy meter, because you just clamp on the transducers to the pipe. The same for the temperature probes. So no drilling, cutting, or welding, and also no safety issues. So you do not have to take care about fire safety if someone starts welding in any place in your estates. So this is also improved on safety for your systems. So as said, we provide the solutions for basically all energy management relevant fluid media, and so the goal, of course, would be to get all this information to your building management system or to a dedicated energy management system. And this is an example here where you can monitor your chiller to be sure that you are within your efficiency and that you can take measures as soon as you run out of efficiency, and that you always run at the best efficiency and do not waste energy. And this is easy to integrate just by our bus systems, Modbus, MBus, and so on, so that you can easily get the data out of the meter all at once, flow, energy, temperature information, and get the conclusions out of it. And best, of course, to let you help with a dedicated software. Another very important point here is the quality of the measurement. So what you get with each individual fleximeter and transducer separately are calibration certificates. And this is very important. This is not a system that is just some play around meter to have an indication of flow. No, this is really a serious thing, and so we provide those calibration certificates with a very unique factory calibration system. This what we call aperture calibration. This is something that Flexim invented and has a patent on it. But in the end, what we have is a 0.3% measuring system accuracy when you are on the calibration, and for the actual field application, we specify an uncertainty of 1%. So this is what you get: 1% accuracy in the field when you put our transducers on any given pipe. If you'd like to learn more here, you can visit our YouTube channel and see how this aperture calibration works. This is quite interesting. Also, what we're going to introduce is the ISO 17025 accreditation, so the standard for an approved calibration laboratory, which has been delayed due to the pandemic, but which will come hopefully by end of this year. So another thing here, very interesting for the practical use, is what I already told you about the portable meter, that it's basically the same principle and can do the same as the fixed installed. So that you have a combination of portable and fixed installed meters is a very economic approach to your energy management and to the road to carbon net zero. Because if you want to have a perfect picture, you would need a lot of installed meters. So you need to purchase them, you need to install them, you need them to hook them up to your system. But there's also the possibility just to have the needed amount of fixed installed meters, and everything else can be covered by portable meters. So this is absolutely okay. And also with the ISO 50001, the standard for energy management system, they say you can use portable data from the field to feed your energy management system and to check your energy efficiency and to get the knowledge about your energy flows. So again, we have this one for all solution. Only one measuring principle is needed for all of these applications, and the combination of those two, portable and fixed installed, makes it, for one, easier to use, and secondly, kind of future-proof, because I said you will have some priority list where you wanted to start, and then you dig your way down to every spot in your estate. So if you have this portable meter that can do all, you never will run out of a tool that will help you. So you have it at hand when you need it, so that you can go on and investigate for further energy saving potentials. Okay, so far for the energy management or the carbon net zero itself. Now I wanted to talk a bit more in detail about our steam measurement. So this is still quite a new solution. We launched this product in end of 2019. And I think steam should be very much in the scope of any carbon net zero investigations, because the thing with steam is, of course, especially in the hospital, is very widely used. So you use it for building heating, warm water generation, especially for the sterilizers and autoclaves, for washing, cleaning, for the HVAC humidification. But of course, the thing is here, basically or mostly you use gas, natural gas, to fire your boiler. And this is, of course, a direct effect of your carbon footprint. You will use a lot of natural fossil fuel, which directly produces a lot of CO2. So this is why steam is, for one, energy intensive, and secondly, a direct effect on your carbon footprint. So it should be very much mandatory to monitor your steam flow for your carbon footprint analysis. For one, of course, how much steam do you actually produce? And secondly, where does it go? Which of your buildings does use most? How much steam do your sterilizers use? And is there any way you can improve the steam consumption? So steam measurement itself is, of course, not a new topic. There are many conventional measuring options, but in the end, they have one thing in common, of course, they are all inline. So as soon as you want to have a steam measurement installed into your system, first thing you need to do is stop your steam process, cut the pipe, open it, drill it, whatsoever. Then you have to install, for example, an orifice plate, what you see on the top left, a vortex meter in the middle, or any kind of differential pressure probe on the right-hand side. So that is something you need to physically install into your pipe, then close everything, weld it up again, make sure it's not leaking, get your safety documentations done, and so on. And then still you have to deal with kind of limited flow range and pressure loss, because all those metering principles have quite something in common, and that is quite a limited flow range. And this is something you need to consider if you're thinking about monitoring your steam flow. You want to reduce your steam flow, so at one point you will achieve that, but then you have a meter installed that would be able to detect those low steam flows anymore. Or even from the beginning, you will have problems metering your steam flow when you are on low demand, like in this time period right now. It is still warm enough that you do not need much heating, and still cool enough that you do not need much air conditioning. So steam demand would be quite low. To give you a better idea about the inline principles, here's one. This is the vortex meter, basically the most common one used for steam nowadays. The thing is here, by the principle, you have your measuring pipe, and you have your kind of obstacle in the pipe that creates those vortices. And the higher the flow velocity of your steam, the more vortices you will generate. So the frequency of vortices will increase. And basically you can measure the number of vortices you have. So basically you do count the number of vortices inside your pipe, and so you get to the actual steam flow. The problem is, to create those vortices, you need a certain amount of flow velocity. And most of the times you do not have it. So what you need to do is artificially rise your flow velocity by reducing the pipe diameter. And this is very common for vortex meters, that you have this for one built into the meter's body, or even have additional pipe diameter reductions in your steam system. So what you're going to do is, you want to save energy. You're installing a measurement by reducing the pipe diameter, increasing your pressure drop, and need more energy to overcome this pressure drop. So this is quite not a good idea, I guess. So, but even bigger problem here, even with those pipe diameter reductions, still those vortex meters and also the orifice plates, the differential pressure meters, they struggle with low flow. So if you are on low demand, you will have problems measuring your steam flow. So here's one example. Just recently, I made these pictures actually yesterday, where I was on site with our service. And this is a real steam measurement installed. You can see it on the right-hand side. The pipe comes up from bottom to top. So this is above a 20-ton steam boiler. So the flow direction goes from right to left. And you have the main pipe diameter is 350 millimeters. So the boiler output pipe diameter is 350 millimeters. But what you see now here is that you need a pipe diameter reduction down to somewhat about 250 millimeters. And here on the left-hand side is the orifice plate, the actual meter. So you now see the problem. You create steam in a big boiler, you have a big pipe, but then you need to turn everything down to another pipe diameter, to a smaller pipe diameter. And even inside the orifice plate, the meter's body is smaller, and the plate itself reduces the diameter again. So you probably have an opening somewhat about 200 millimeters left to get all of your steam through. Same situation, just from another perspective. You have the orifice plate, the smaller diameter, and then it goes back again to the large diameter of 350 millimeters. So I think the problem is obvious. If you're installing those kind of conventional meters, you have to handle those pipe diameter reduction, and this will give you just a bad time with your boiler efficiency. So yeah, let's propose a different solution. Again, here, our transit time measurement, and the same applies to steam. So we just made it this steam measurement. We installed a steam measurement yesterday in the University Hospital Würzburg in Germany. As you can see here, this is the full pipe diameter. There's no need whatsoever to reduce the pipe diameter to have this measurement. You can see our service colleague here is just mounting the transducers on this mounting rail. This is a portable installation, so this is not a fixed one. This is a temporarily, and is supposed to sit there for 2 weeks to have a boiler survey. So to wrap it up here a bit, what we can provide. We have steam measurements non-invasively for steam up to 180 degrees C. This means 180 is probably or typically inside the specifications for building steam, so for your heating process and so on. So this would make it a perfect solution for the building sectors. You install it non-invasively outside the pipe without any pipe diameter reduction and no pressure loss. So why is that without pipe diameter reduction? And basically this is because of the measuring principle. And this is also valid for every application. We have a detection limit, so the lower flow we can detect of 0.01 meters per second, independent of the pipe diameter. So if we take a look here at the example steam application, let's say we have steam at 175 degrees C. This would be a density of 4.5 kilograms per cubic meter, and this is the number you need to calculate those conventional flow rates. We have a lower limit here. I put it to 0.025, which is our factory setting for the low end of the flow range. And this would be a minimum flow velocity we can detect of 3.45 meters per second. And in comparison to that, we have, sorry, I was wrong. This would be a mass flow of 3.74 kilograms per hour. So we have we start measuring at 0.025 meters per second, and accordingly, the correlated mass flow in a DIN 100 pipe, 4-inch pipe, would be 3.74 kilograms per hour. Against this, we have a conventional meter, for example, a vortex meter, which would be starting measuring only at 3.45 meters per second. So the minimum flow that you are able to see is 516 kilograms per hour, so much higher. So this not so what does it mean? It's not necessarily like a kind of leakage meter or a low flow meter. It just means that you have this whole flow range available, 0.025 to 35 meters per second, without the pipe diameter reduction. And back again to the Würzburg application. Pipe diameter is 350 millimeters. We have saturated steam at 165 degrees C, and we can measure a flow range between 3.74 and 41,000 kilograms per hour, so 41 tons. And this is again without any need of pipe diameter reduction and so on. Okay, so just quickly, the main specifications here where you can measure steam. Basically, pipe diameter range starts at 23 millimeters up to 1,000. It is for saturated and overheated steam, so we like to have dry steam actually. And the operating temperature that you need for our transducers is 135 to 180 degrees C. This is why, because we need a certain minimum pressure to be able to set up a gas measurement, and this is 2 bar G or 3 bar absolute. And this is accordingly a saturated steam temperature at 135 and 180 max, because this is what the transducer can stand. For the flow velocities, we can go as high as 60 meters per second. So this is very much enough for most applications, as you like to have something between 20 to maximum 30 meters in your steam applications. You shouldn't go higher with that. Accuracy for our steam measurement is specified with 1 to 3% of reading. Okay, so as I said, for a final wrap up here, what we propose here, or what our solution is, that we have a great solution for your estate management toolbox, that we can do all of those relevant media that you want to monitor if you're going for carbon net zero, like water, gases, energy, and steam. And this is, everything is with the same measuring principle. Everything is similar to install, so you do not have to handle different types of meters, different kind of installation methods, and so on. So, which will make it much easier for you to use and to get to your goal of carbon net zero. So that would be it for the presentation. And again, here announcement. Perhaps Andy, you would like to take over. I think this is your your favorite event here, the Healthcare Estates Conference in October.
Thanks very much, Lars. That was a very helpful and very detailed energy presentation. I regret there's some people mentioning comments on the questions that the sound seems to have stopped for some of them. I hope it's only a minority, but yeah, in summary, for anyone who has lost sound and needs to catch up on this, I think it's being recorded, so you should be able to download it and play it back again. Perhaps the organisers can confirm that at the end. But yes, we are at this exhibition in Manchester. It's a week worth of webinars, but there are 2 days of physical exhibition, the 19th and 20th of October. We will have demonstration equipment there, and we really welcome the opportunity to meet you and discuss your own individual requirements. So thank you very much for your attention, and finally, it's whether you have any specific questions for Lars or I.
Hi, thank you very much, gentlemen, for a very interesting presentation. I'm sorry that 1 or 2 people appear to have had sound issues, but we are recording this and it will be downloadable subsequently, so that should be helpful. We've had 1 or 2 questions, but if anybody wants to put any others, if they can type them into the sidebar where it says questions on the webinar interface, that would be great. 1 or 2 questions. If I can just ask you, how long has Flexim been going, and has clamp-on metering always been its key business?
Lars, do you want to answer that one?
Yeah, sure. So yeah, yes, so Flexim was founded in 1990, based on basically a project from some guys from the University of Rostock, and basically, yes, we only do clamp-on metering. So that is this thing where we see ourselves as a top technology leader and the specialist for clamp-on metering, because we do still a lot of research and development on the clamp-on metering systems, and this is why we have such very high-end solutions like the steam metering, gas measurements, which is quite unique on the market for clamp-on. But this is correct, we only handle clamp-on measurements, and this is the way we do all of our flow measurements.
And did the oxygen clamp-on metering come first and the other systems develop subsequently? Was that the way it happened?
I think that all ultrasonic clamp-on flow measurements started with liquids originally, way back in the day. Yeah, there's very few clamp-on companies who have managed to take that forward into the arena of gases, but we are very, very successful at gas measurement. So even your gas distribution networks, whether you get your gas from Cadent or from Southern Gas Networks, Northern Gas Networks, these gas networks use clamp-on ultrasonics as well for natural gas flow measurements.
That's interesting. During the pandemic, clearly there were all sorts of oxygen flow and capacity issues in hospitals across the UK, some of them quite unanticipated because obviously the situation hadn't arisen before. Did you see a spike in demand for your systems during this time?
Yeah, it's been unprecedented, frankly. Yeah, I mean, the hospitals, all their systems were based on pressure. It just doesn't give the granularity, the detail, minute by minute on what's going on in your oxygen system. So yes, we just from March 2020, it just exploded. It's now obviously calmed down significantly, but no, it's been a continuous demand since the pandemic.
Somebody else has asked, I mean, can hospital engineers or healthcare estate management teams undertake the installation of the flow meters themselves, or is it something you recommend that your own engineers or agents complete?
Installation, if we're looking at portable meters and clients purchasing their own portable meters for their own surveys, if it's liquids, anyone can do it, I would say. But if it's gases, we would provide training alongside the instrument to train you how to get a gas measurement or a steam measurement. But yeah, if it's a fixed installation, then obviously we would provide commissioning services, or indeed we sometimes supply through medical gas pipeline installers, and those companies that we deal with have been trained as well to do commissioning.
Thank you. Another question is, how much pipe inlet and outlet straight run are needed for a typical application?
If you're looking for the optimum accuracy, we're looking for typically 10 diameters of straight length upstream and 5 diameters downstream. We can work with less, the accuracy will be less, but you can generally work with the repeatability. So if you're using it for monitoring and control purposes rather than for absolute accuracy, you can rely on the 0.15% repeatability. Let's say we were right next to a bend and you're achieving an accuracy of -4, -5%, something like that. It will repeatably hit the same flow measurement every time you get to that level of flow. So 10 and 5 is ideal. If you haven't got it, we can come and we can give you a survey. We can advise on best practice and what likely accuracy you may achieve.
So somebody else has asked what sort of maintenance the systems need, and is there a need for recalibration of the transducers or any of the equipment at any stage?
It's a very, very good question. For fixed installations, we couple to the pipe with a fluoroelastomer. It's like a rubber pad, and there's zero maintenance with that. You can fit it, you can forget it. The UK water industry frequently bury our flow meters. Once they're buried, they're expected to be there for 10 years without any maintenance. So a fixed fluoroelastomer pad means zero maintenance. Calibration, that's entirely up to the client and how much they need it from their quality management perspective. I mean, if you want a recommendation, there is no drift on our meters, so you could say there is no need for maintenance, but a recommendation for those who require it for their quality management systems is that for a fixed meter, recalibrate once every 5 years. We are in the process of encouraging and educating our clients away from recalibration to verification. And we have verification software that will tell you there has been zero drift, zero degradation outside prescribed tolerances since installed. And if you verify it on an annual basis, no need to do anything. And we can produce a verification report certificate. So that's the way we're going with many industries.
That's interesting, thank you. Another question, does the pipe material for steam measurements matter? Does that have an impact?
I'll let Lars answer that.
Yeah, basically not. What we can work with, or in general, the clamp-on system works with all pipe material. So we have a lot of copper pipes for the oxygen measurements. We have the standard carbon steel for all kind of liquid measurements with thermal energy and so on. And we see, of course, a lot of carbon steel as well as stainless steel in steam. So basically, for steam, you rather either find carbon steel or you will find stainless steel. In the end, it doesn't matter much. What you want to make sure is that you have the proper transducer for the proper wall thicknesses. So you have, depending on the pipe material, different wall thicknesses for the same pipe size. So this is something we just need to know. We just need to consider. We need to know the pipe material and the wall thickness in advance, or at least roughly. But in the end, pipe material doesn't matter much for us, as we just tell the meter which pipe material we have, and we make sure that you get the right transducer, and then you're basically good to go. So in the end, it's something you just set up for the meter which pipe material you have.
Thank you. There's another question. Does the insulation need to be removed from pipework during measurements?
Can you tell again? I didn't get the.
Does the insulation need to be moved from pipes during measurement?
Yeah, of course. So you need to place the transducers, the ultrasonic transducers, directly onto your measuring pipe. So you need to open up the insulation for installation. So if you want to, you put the transducers onto the pipe. So you remove the insulation for about, let's say, 50 centimeters, half a meter or something, that you have some working place, put on the transducer, but then absolutely you can easily wrap it up again into the installation. And this is definitely recommended to do so, that you do not have energy losses, and definitely for steam measurements, as you do not want to have condensation on your measuring spot. So yes, remove insulation, install the transducers, and put it back on again. And typically the transducers are in that size and slim enough that you can easily insulate them back again.
Thank you. There's one or two more sort of technical questions. One is, what communication bus outlets are available?
There's a multitude of bus outputs that we can offer: Modbus, Mbus, Profibus, BACnet. You know, the list is quite extensive. If anyone's got any comms connectivity issues that they wish us to consider, we'll let you know exactly what we can and can't do. But yeah, I think all the common buses we have.
There's another question is, what power supply is required for a system?
You can use 24 volts DC or 110 to 230 volts AC. So, you know, we've got options for any type of power.
And what about the minimum and maximum pipe sizes you can work with the clamp-on metering?
Yeah, you won't see this with your hot water, steam and such like pipes, but we can go down to 6 millimeters. And we go all the way up to 6.5 meters on hydroelectric pipes. So yeah, I don't think there's any pipe sizes that will be an issue within the hospital estates.
Does the number of meters, clamp-on meters that hospitals require, does it vary a lot depending on the size of the premises, the estate, the number of wards, the number of patient facilities? Can it vary greatly?
Well, I mean, you're going to get a multitude of different sizes, but actually, and again, some hospitals, smaller hospitals, if we talk about oxygen, they might only have 1 meter. Bigger hospitals might have 10, 15. But one of the things we haven't touched upon is you can actually have a fixed meter running 2 flow measurements. If we use a dual channel meter, it could be doing a flow line over here that's 2 inches. It could be doing a flow line over here that's only, 15 mil. So we can do multiple measurements with a single meter.
Are you seeing, I mean, presumably you're seeing a great increase in demand for measuring of sort of different energy formats because of pressure for net zero at the moment? That presumably must be making quite a difference.
I think the drive to net zero is a public drive in almost every country, certainly in Europe. But certainly the UK government is making it a big push. We've done an awful lot of work with the hospitals estates on oxygen. We've scratched the surface with energy. We've done a few. You've seen some of the examples on screen. I think there's an awful lot more we can do to support the estates in their net zero ambitions.
And presumably the UK is a growing market for Flexim now.
Indeed. And just to finalise on that energy part, if you look at the government's websites, they've actually identified that the hospital estates, don't quote me on this exact number, but I think it's something like 5% of the whole of the UK's carbon is generated from the hospital estates. So the hospital estates is a big contributor to carbon and has a big potential for reducing the UK's total net carbon output.
Thank you very much. There are no other questions at the moment. Is there anything either of you would like to add about the systems before we conclude?
I think that we've covered everything. Lars, anything?
Well, I think so. I mean, the bottom line would be here that you shouldn't be, I don't know, afraid of tackling this carbon net zero thing. And I would say, get in touch with Flexim UK and show them what you have, what you want to do, and they will find a solution and probably showing you the portable meters, showing how it works. This is, I think, something would be common. Get in contact, get to know the metering principle and how easy it's to use on your site, on the estate, and then, yeah, let the meter speak it, so to say.
Thank you very much, gentlemen. That was a very interesting engineering related presentation. I think you explained the benefits extremely well. As we said, apologies if some people have had sound issues. It seems to be just a number of them, but not everybody. So I'm not sure what the reason for that is, but there will be a recording of the complete webinar available subsequently. Thank you, Lars and Andy, for your time, for giving an excellent presentation. And thank you for everybody who's attended. And with that, we'll conclude the webinar. Thank you.
Thank you very much.
Thank you. Have a good day.
Cheers.